The Russ Prize is the premier prize in bioengineering. It was originally awarded in the year 2001 and is awarded every other year. It's awarded by the National Academy of Engineering in cooperation with Ohio University. Fritz was one of the original entrepreneurs after World War II in the electronics industry. He and his wife Dolores formed their company in the early 1950s. They dug the foundation for their original building themselves. When they sold the company in 1987, it was one of the largest engineering consulting firms in the country. They lived modestly, even though they were very wealthy people at the end of their lives. They started the award because Fritz was always concerned that the Nobel Prize was not awarded in engineering. He conceived the Russ Prize to fill that gap. The type of person that would win the Russ Prize is someone who would take a basic scientific concept, apply engineering principles, and solve a practical problem. That practical problem, in the case of the Russ Prize, would have significant impact, be in widespread use, and improve the human condition. Fritz was known for thinking 20 or 30 years into the future. In fact, I would say that his impact on Ohio University itself is to inspire us and to set the example for long-term visionary thinking. Examples of past winners of the Russ Prize have included the inventors of the implantable heart pacemaker, the inventor of kidney dialysis, the inventor of the automated DNA sequencer, and the inventor of the enabling technology for heart-lung machines. The Russes wanted to ensure in perpetuity that achievements such as these continued to be awarded, and thereby inspiring a new generation of engineers.
The 2013 Fritz J. and Dolores H. Russ Prize is awarded to Rangaswamy Srinivasan, President and founder of UV Tech Associates, James J. Wynn, Program Manager at the IBM T.J. Watson Research Center, and Samuel Blum, retired from the IBM T.J. Watson Research Center. In 1981, while working at the IBM Research Center, Srinivasan, Wynn, and Blum discovered that pulsed laser radiation at 193 nanometers from an argon fluoride excimer laser could etch animal tissue with sub-micron precision without causing thermal damage to the adjacent tissue. The initial discovery was made on November 27, 1981, when Srinivasan brought leftovers from his Thanksgiving meal into the lab. He irradiated turkey cartilage with pulses of light from the excimer laser and found it made a clean incision in the tissue. In parallel studies, Wynn found that pulsed laser radiation at 532 nanometers from a Q-switched frequency-doubled neodymium YAG laser left a burned and damaged region of tissue. In 1982 and 1983, Srinivasan and Wynn obtained human arterial tissue and irradiated a segment of the aorta with both types of lasers, and the importance of the laser source was confirmed. The excimer laser, again, proved to be the preferred laser source, leaving no detectable evidence of thermal damage to the underlying and adjacent tissue. In 1983, Srinivasan, Bodo Braren from IBM, and ophthalmologist Stephen Trokel published a paper on the potential for laser eye surgery in the American Journal of Ophthalmology. The publication detailed excimer laser experiments on several enucleated calf eyes and is regarded by the ophthalmic community as a seminal paper in laser refractive eye surgery. By the end of 2011, ablative photodecomposition for corrective eye surgery, known today as PRK and LASIK, had allowed approximately 25 million people to improve their eyesight. This procedure was made possible through the investigations of the interactions between human tissue and light of Rangaswamy Srinivasan, James J. Wynn, and Samuel Blum. And for this, we award these pioneers the Fritz J. and Dolores H. Russ Prize.